Hello everyone. Welcome back to this ETABS Training Series, which we prepared to help you gain mastery in operating the software. Following up on previous session, where we had the opportunity to explore the different components of the user interface, on this second lesson, we will start our revision of the commands offered by the different ETABS menus. We'll quickly revise some of the typical commands offered by the File menu, with particular emphasis on how to work with the ETABS EDB and E2K text files. And we'll then move on to the Edit menu, where, besides other typical Windows-based operations, we'll focus our attention on the definition of stories in ETABS, and how to set up coordinate systems and corresponding grids. If you're new here, please make sure to click that subscribe button. Let's jump into it. Next up on our list of components of the Windows-based graphical user interface embedded with ETABS is the list of top drop-down menus. Starting from left to right, the first one on our list is the File menu. Here you'll find options to start a new model, open an existing model, open a recently saved model, save the model, import and export capabilities, close the model and the software, create reports, capture images, and create video animations. Let's see how to use these features in ETABS. On the File menu you find options to start a new model, open an existing model, and save the model you're currently working on. Speaking of which, let's take a moment to save our model, using Command File, Save As. Browse to the location where you want to save your model. We recommend creating a dedicated folder for it. After running the model, the software will create a significant number of files, and it will be a good practice to keep the generated files saved all together in a specific directory. Now that you save the model, please notice as the title bar displays the name of the model. Let's quickly investigate the files that were automatically created inside the folder, as soon as you save the model. From these, I want to raise your awareness for two of them in particular, these being the EDB and the E2K files. Starting with the EDB file, this is the typical working file you'll use on a daily basis. When you launch the software and open an existing file, you will usually be loading the EDB file of the model. Together with the EDB file, we always recommend you to keep the E2K file on your records. The E2K file is in fact a text file. This means you can open it with a text editor, such as Notepad, and you can check that it includes all the information pertaining to your model. In situations where you need to use models prepared in previous versions of the software, for instance, it is always a good idea to import them from their corresponding E2K text file, instead of launching them directly from the EDB, thus preventing any possible import errors. Getting back to our discussion regarding the File menu. Next you'll have access to all the import and export options offered by the software, allowing you to easily exchange information between ETABS and other pieces of software. In line with what we were just reviewing a moment ago, ETABS starts by giving you the option to import and export the E2K text file of your model. Another option you'll probably use on a regular basis is the import and export capability to Excel. In addition to these, we should probably also stress the importance of the interoperability with other pieces of software, such as AutoCAD and Revit. Still under the File menu, you find other useful options, such as the Print Graphics command, which allows you to automatically generate a print of the model, showing on the working window. Or the Capture Picture, which, for instance, allows to capture images in BMP format, either from each or the working windows, or the entire screen. This command also allows you to automatically generate DXF and PDF files of the views showing on the working windows. Another useful feature for you to be aware of is the Create Video Animation command. Use the File menu, Create Video, Multi-Step Animation command to create videos in ETABS, showing the movement of the structure during any nonlinear static, nonlinear staged construction, or time history analysis that has been run. When you create and save the video, ETABS generates an AVI video file, which you can then play, to check, for instance, movement of the structure over time. Another important command available under the File menu is the Create Report. When you select the option User Report, the software allows you to specify the tables and images you want to include on the automated report, in terms of general information, structural definitions, assignments, and so on. As a reminder, when revising the features offered by the Model Explorer, we briefly covered how to generate the automated reports, which become available under the Reports tab, and are subsequently displayed on the report viewer. Wrapping up the revision of the File menu, A final note to say that it also gives you options to close or exit the software, and to open recent files, for which the software still has the save path in memory. Next up on our list of top drop-down menus is the Edit menu. On this lesson you can expect to learn about the following features offered by the Edit menu. Options to undo and redo, cut, copy, paste and delete. Introducing the multiple towers feature. Master and similar stories definition. Introducing the global coordinate system. Adding coordinate systems and grids. Adding grid lines, using selected joints. And revision of additional commands to tweak both grid and dimension lines. Let's briefly revise how to use these features on ETABS. We are now in a position to move towards the Edit menu. As expected, this menu will offer you the typical commands to easily manipulate your model, including operations like undo and redo, cut, copy, paste and delete. Another command that you'll regularly use in ETABS is the Edit Storeys and Grid Systems. Basically, this is the command that allows you to control the grid systems and the stories definitions. ETABS offers the possibility of working with multiple towers on the same model. This is useful when you want to get results per tower and you want to take into consideration the behavior and interaction between different towers in the same model. When more than one tower is expected to be included on the same model, one of the first things you need to do is activating the Multiple Towers feature under the Options, Allow Multiple Towers command. The reason we're raising your awareness for this option at this point is that when the Multiple Towers feature is activated, then the name of the Stories and Grid Systems command is actually revised to reflect this, becoming Edit Towers, Stories and Grid Systems. For the moment though, let's try to keep things simple and work with just the one tower. So we're going to deactivate the Multiple Towers feature for now. When you want to deactivate the Multiple Towers feature, the software asks you what the surviving tower is. Once we haven't actually added any additional tower, let's just keep the default tower T1 and delete any others. The concept of working with stories is fundamental when operating ETABS. On this chapter, we'll thus have the opportunity to explore the features offered by the program to prepare the stories information, and understand how ETABS will then interpret and use that information for modeling purposes. We'll start with a quick overview of the story information, including story name, height, elevation, color, etc. Next we'll address how to set up master and similar stories, and delve into how this information affects modeling operations. When required, we'll show how to specify column splices. We'll then explore some editing operations of the story data menu, including copy-paste. And lastly, we will revise the options to add and remove stories. Now on ETABS. Let's take a moment to talk about working with stories in ETABS. One of the most powerful features that ETABS offers is the recognition of story levels, allowing for the input of building data in a logical and convenient manner. As a reminder, when we prepared the template model, we accepted the default number of 4 stories. Moreover, the template is assuming all of them are exactly the same. This is reflected on the information you get here on the story data command. The first column on the form identifies the different stories, with editable names should the user wish to rename them. On the next column of the table, the user can control the different heights of each story. Once we specified all stories were 3 meters high when accepting the template, that is what is being considered here, but this information can also be modified. Up next is the elevations information. As they are automatically calculated, based on the heights specified on the precedent column, the story elevations are grayed out, with exception of the elevation at the base, which can be edited. And by default is assumed as 0, but user can change this, and can even specify a negative base elevation to represent basement floors. Understanding the next 2 columns, the master story and the similar to, is paramount to work proficiently with ETABS, and to take full advantage of the modeling techniques offered by the software, with a view to expedite the modeling process. We mentioned that ETABS is specifically prepared for the analysis and design of multi-story buildings. More often than not, multi-story buildings have repetitive floor plans throughout several different elevations. That is precisely what ETABS is trying to explore, when offering the concept of master stories and stories similar to. The advantage of defining the master and similar stories is that, whenever you have repetitive floors on your building, and, provided the similar stories option is activated, you can model just one of the floors that share the same floor plan, and all the information is automatically replicated to all the similar floors, thus drastically reducing the time spent on modeling and design. The information that can be replicated in this fashion includes drawing the geometry, selection of elements on screen, and load assignments as well. To help us understand this, let's imagine for a moment that our 4-story building has in fact 2 different floor plans, one for the 2 bottom stories and the other for the 2 upper stories. The first step consists in defining the number of different floor plans that exist on the building. That number reflects the number of master stories you'll need, so for this example, we require 2 master stories. It doesn't really matter which of the stories that share the same floor plan is considered as the master of their similars, provided that the similar to column reflects the information correctly. Meaning, we can either assume that floors 1 and 3 are masters, in which case, 2 is similar to 1, and 4 is similar to 3. Or, you can specify that the masters are in fact stories 2 and 4. In which case 1 is similar to 2, and 3 is similar to 4. The result will be the same. After defining the information of the master and similar stories, you can then specify that when working on the software, you want to activate the similar stories option. This information is available on this dropdown, on the right bottom corner of the screen. Options are given to work over 1 story only. This is the default option. When this option is selected, any objects drawn in plan occur only at the level where they are drawn. Likewise, an assignment made in a plan view applies only to the object, or objects, actually selected. And similarly, a selection made in a plan view applies only to the object, or objects, actually selected. Work over all stories. When this option is selected, then an object drawn in plan occurs at all story levels, except the base. When an object is selected in plan view, objects of the same type, and in the same location at all other story levels, except the base, also get selected. Provided that an object of the same type, and in the same plan location as the selected object exists, then an assignment made to an object in a plan view also occurs at all story levels, except the base level. Work with the similar stories option. When this option is selected, independently of you having in display either a view of the master story, or one of the similar to stories, any object drawn in plan or 3D view will occur at the master story, and at all stories that are designated as similar to it. Object selection and assignment behave in a manner similar to the drawing operations, that is, selection of one object will result in objects of the same type, and in the same location, on similar stories, to also be selected, and, where appropriate, assignments made. As an example, once we have defined floors 3 and 4 as similar and we're currently displaying a plan view of story 4, with the similar stories option activated, when selecting the story on screen, both stories 3 and 4 get selected, as shown on the 3D view. A note to stress that the similar story feature is never intended to be regarded as something that might constrain the user. On the contrary, it's a feature intended to help user expedite the modeling operations, particularly when the model has repetitive floor plans. This being said, it's important to clarify that, at any moment while operating the software, the information related with master and similar stories specified on the stories definition window will only be considered when the similar stories is selected. If the dropdown is set to 1 story, then this information is ignored, and all drawing, selection and assignment operations will only be performed over the floor displayed on the working window. This means that, if at some point you have floors that are similar in almost every aspect, but let's say, one of them has a specific load, which is different to the loads of their similar floors, what you need to do is, keep the similar stories option activated while drawing the similar floors, select them, and make all the necessary assignments that are shared across the similar floors, and then, once all the information that is similar to all floors has been added, you can just switch the dropdown back to 1 story, to add information which is exclusive to a specific floor. This allows the user to keep all the information added to the model while the similar stories option was activated, as well as allowing to now make changes, including any drawing, selection, and/or assignment operations that pertain only to the floor currently displayed on the working window. Just a couple of final notes concerning stories, to say that ETABS offers the quick Add Story option, which basically adds a new story at the top of the building, and, by default, sets it as a master story, so similar to none. The user can then revise this information if necessary. Also, please note as all master stories are similar to none. Only stories that are not masters can be similar either to a master or to none. The roof of the building often has a floor plan that is different from all the other stories on the building. When the building has a floor plan that is specific to 1 story only, you can set it up one of 2 ways. Either you define it as being a master story, and make sure that none of the other stories that are not masters end up being defined as similar to it. Or, you specify it as not being a master, but also as not similar to any masters defined on the model. In other words, it's similar to none. Both approaches work as if you had the option work over one story only activated, that is, all drawing, selection and assignment commands made over the story will not be replicated to any other stories. A quick note to stress that the base level is neither a master story, nor can it be similar to any other stories. Basically, the only way to draw structural components on the base level is working over its plan view, or draw in 3D view, with the working plan dropdown set to base. If you remember, we actually had the opportunity to illustrate how to set the base level as the working plan, when showcasing the features offered by the ETABS working windows. On a different topic, when you have steel columns on your model, for which you need to identify splice locations, the software allows you to specify the splice story and splice height on the story data form. Use these columns to specify if a splice occurs at this story level, and, if yes, then the software unlocks the splice height column, so the user can input the height data. The splice height is the distance from the bottom of the considered story, up to the column splice location. Only stories that are set to yes on the splice story column offer the possibility to edit the splice height. For example, if yes is selected for story 3, the splice occurs at the specified height between story 2 and story 3. To display splices, check the column Splices item on the Object Assignments tab of the Set View Options form. Getting back to our story data form, it's also worth raising your awareness for the last column on the form, which allows the user to apply a different color to each story. The user can then refer to the Set View Options command to activate View by Colors of Stories. When right-clicking the spreadsheet area of the story data form, options are given to copy-paste information. This applies, for instance, to information between different cells on the table. Additionally, you can also copy data to other applications, such as Excel. Still on the spreadsheet area of the story data form, you can also refer to the Add Story, Keep Existing Story Heights command, which allows you to add one or more stories at once, specifying their heights. Elevations will be automatically calculated, based on height specified for the new stories. You can also select above which story should the new story, or stories, be added, and what existing story should be used as the basis to replicate the new one, or ones. If the story to be added is different from all the existing ones, just use option None, in which case, ETABS adds grid lines for the new story, but leaves it without any geometry. If instead you refer to the Add Story, Keeping Existing Story Elevations command, then you'll be prompted with the form to indicate the elevation at which the new story should be added. If the elevation specified for the added story is less than the elevation of the existing story above, the program will adjust the height of the story above. This height can then be readjusted as needed. Unlike the previous command, where user is given the option to select which story should be used to replicate the new stories, when using the Add Story, Keeping Existing Story Elevations command, the program creates the new story, with corresponding grid lines, but no geometry is ever added. The software automatically assigns sequentially numbered names to the added stories, that is story 1, story 2 and so on. This explains why the most recently added story, though not being the top story, is currently assigned the higher numerical story number. User can refer to command Set Story Names to Default, to reorder the names, in which case the story names will be sequentially ordered by ascending elevation. As a reminder, the story names are editable, so it is worth mentioning that when using this command any user-defined names will also revert to default. The Set Story Names to Default command is also available here. User can delete data from the story data form, using for instance command, delete story, delete existing structure at story. This command deletes the story level as well as the structure for that story, resulting in a reduction of the overall height of the structure. In other words, the elevation of the top story is reduced by the height of the deleted story. If after deleting a story, the user wants to see that change reflected on the current model in display, while still inside the story data form, then the user can refer to the Refresh View command, available here, and here. Finally, if the user wants to delete a story level, while retaining its overall structure, this is made possible by referring to the Delete Story, keep existing structure at story command. In this case, the height of the deleted story is added to the height of the story level above it. To confirm this, imagine we delete story 2, but stipulate that we want to keep its structure. Based on what was just said, the structure of previous story 2 will now be part of story 3. The software immediately assumes that the new height of story 3 is the sum of its previous height, plus the height of the deleted story 2, so total height 6 meters. The elevation is also automatically revised to 9 meters. If you use the refresh view in this situation, the software would internally update the model, but this change wouldn't actually affect how the model looks like. In order to confirm that story 2 has indeed been deleted, what you can do is, for instance, revise the list of plan views available on the model, and check that story 2 is no longer available. Moreover, if you select story 3, the 3D view shows 2 consecutive floors selected, once all the objects of previously existing story 2 have now been assigned to story 3. You can also check that both slabs located at elevations 6 and 9 meters are now both assigned to story 3. On this chapter we'll have the opportunity to revise all the topics and features you need to know about grid and dimension lines. We'll start by discussing why we recommend having grid lines on your model, and how they will help you manipulate it. We'll then introduce you to the global coordinate system, and illustrate how, ultimately, all locations on your model are defined with respect to this system. We'll then move on to revise all the information required to define the grid lines, including the location of the origin of the associated coordinate system, the definition of the range of stories the system refers to, indication of the name and location of the grid lines, etc. Next, let's define general grid lines, that is, grids that have a random direction and plan, instead of being aligned with the default X and Y directions. We will also demonstrate how to define reference planes and reference points and their purpose. ETABS allows to work with multiple coordinate systems on the same model. Let's see how to define and permute between them. We'll revise the visibility commands offered by the program, to control visibility of the grid lines. There will also be an opportunity to check additional grid data parameters, including bubbles, grid colors, etc. How to import general grid lines from DXF files. Finally, we'll revise some additional grid-related commands, including how to add additional grid lines at selected joints. How to adjust model, using the glue to grid lines command. And lastly, how to delete and reshape grid lines, using the lock on screen grid system edit command. Now on ETABS. Now that we have covered how to work with stories in ETABS, and with similar stories in particular, the next topic that we need to discuss is the definition of the grids. Defining a grid system allows for the rapid and accurate placement of objects when drawing. Grid lines also determine object meshing, allow for easy snap to grid operations, and define the location of elevation views. To talk about grid systems, we first need to introduce you to the global coordinate system. Once every grid system is, in fact, defined by specifying its origin and orientation, with respect to the fixed global coordinate system. Ultimately, all locations in the model are defined with respect to a single global coordinate system. Identified as global, this is a three-dimensional Cartesian coordinate system, that cannot be deleted, so it always exists. Its three axes, denoted x, y, z, are mutually perpendicular, and satisfy the right-hand rule, which origin is displayed on screen, corresponding to coordinates 0, 0, 0. Each global axis is represented by a color on the interface, being x red, y green and z blue. ETABS always considers the plus z direction as upward. By default, gravity acts in the minus z direction. You can toggle the global axis visibility on or off, using command, view, show axes. Now that we've covered the importance of the global coordinate system, we're in a position to talk about definition of the grid lines in more detail. That being said, here's a quick side note, regarding the options that are given here. 2. Add something new. Add a copy of something existent. Modify show something existent. And delete something. To say that these are commands you'll find throughout the use of ETABS, in many other forms to input data, that being the reason why we wanted to highlight them immediately. Their names are somewhat self-explanatory, but just in case you wonder, these commands will basically respectively allow you to input new data of a specific type. In this particular case, we're inputting grid lines data, but it could be a material, a section, etc. Copy information of an existing item, inheriting the information from the original item whenever possible. Edit and change the information of a given input data. And delete an item. Bear in mind that this is just the first of many times you'll be given these options, while inputting data into ETABS. If you edit the default grid system G1, you can see that options are given too. Change the origin of the system. As a reminder, in line with what we have just discussed, each grid system is positioned with respect to the global system, which means that if you specify a different origin, it will be calculated with respect to the origin of the global coordinate system. Specify the range of stories to which the current grid system applies. By default, the option to all stories is selected. Define the number and location of the grid lines in both horizontal X and Y directions. This information can be inputted as ordinates or spacing. Grid lines don't necessarily need to lie in the X and Y directions. In fact, general grids, which are basically arbitrarily defined grid lines, may be added into a Cartesian grid system, and will work similarly to any other regular grid lines. In order to create general grids, with the orientation you require, you just need to specify the coordinates of the start joint and the end joint of each general grid line. Once you input this information, the general grids are displayed on the sketch on top of the form, together with the other regular grid lines, and will also become available on screen. If you want to use a general grid line to help you locate your structural elements, as soon as you add it under the grid's definition, elevation views using the general grids can be displayed, and the general grids will also be shown both in plan and 3D views, in a similar fashion as any other regular grids. This is in line with what is currently exposed on screen, where the active working window displays an elevation view of a general grid, whilst the plan and 3D views, with the bounding box command activated, show a cyan plan, identifying the location of the general grid. Sometimes, you want to draw elements at a specific elevation, but you don't necessarily want to have a story at that elevation. In those situations, you can refer to the Reference Planes button, which allows you to create a plan view at a specific elevation. If you look at an elevation view of the model, you can now clearly see that a new line has been added at the new elevation. Likewise, you can now also display the corresponding plan view at the new elevation. Another useful command available on the grid data form is the reference points. Use the reference points form to specify the location of a reference point, that is then projected as a vertical line. Click the Add button and then specify the location of the X and Y coordinates, measured with respect to the grid system origin. If you zoom in on the location where you added the reference point, you can see that it has now become available on the model views. If you flick through the different stories, you can check that the reference point was added at all stories. You can snap to the reference point the same way you snap to grid points. This comes to show how versatile this command is, once it allows user to have these additional joints, that though not being objects of the finite element model, are very helpful to guide in construction of the model, like any other grid lines. To aid you in developing and viewing the model, the software offers you the possibility to define multiple coordinate systems on the same model. To add an additional system, select the option Add New Grid System. For each coordinate system, a three-dimensional grid system would be defined, consisting of construction lines that are used for locating objects in the model. Each coordinate grid system may be of Cartesian or cylindrical definition, and is positioned with respect to the global system. As soon as the second grid system is created, both coordinate systems become available on the interface. Both Cartesian and cylindrical grid systems can coexist on the same model. This is particularly useful when the geometry of the structure has parts that follow a Cartesian distribution, whilst other parts are cylindrical. As we've been stressing, the origin of the grid system is defined with respect to the origin of the global coordinate system. You can also refer to the story range data, to specify to which stories these different grid systems apply, meaning that each grid system can pertain to a specific range of stories. The new cylindrical system is displayed on the sketch, illustrating the different radius and theta angles in use. As soon as the grid data information is concluded, user can refer to drop-down of the coordinate systems, available on the bottom right corner of the screen. By default, the drop-down is set to global, which, as expected, refers to the global coordinate system. You can see that the origin of the global coordinate system is displayed. You can switch to coordinate system G1, which shares the same origin as that of the global coordinate system. If you switch to the cylindrical coordinate system G2 just created, you'll notice that the location of the origin of the coordinate system is updated to reflect that of the origin of coordinate system G2. On the other hand, you may be wondering why the cylindrical grid lines are not displayed. The reason is that we've set the range of stories to which this grid system pertains to be only from story 2 to story 3. If we display a plan view of story 2, then the cylindrical grid lines are presented as expected. Currently, both grid systems G1 and G2 are simultaneously displayed, but user is actually given the possibility to control which coordinate systems are visible at any given time, using command view, set grid visibility. If we remove system G1 from the list of visible coordinate systems and hit the Apply button, ETABS hides coordinate system G1 from the view. By default, this command applies to the active working window only, but user can refer to the Apply to All Windows command, thus assigning the action to all working windows. A side note to introduce you to the difference between the OK and Apply buttons. When the command offers these two buttons, it means that user can refer to the Apply button to immediately update the model on screen, whilst keeping the current command available. When knowing that the same operation is expected to be performed more than once, using the Apply button avoids the need to have to repopulate the command for as many times as the operations are to be repeated. If user hits the OK button instead, the software accepts the operation and closes the form. As expected, if the Close button is selected, then the form closes without assuming the operation. The Set View Grid Visibility command also offers options to hide all grid lines in window, hide all reference points in window, and hide all reference planes in window. ETABS also includes an option to control visibility of the global axes of the coordinate system in use. Please refer to Command View, Show Axes, to add or remove the current grid system axes from view. Just some final housekeeping notes on the grid data before moving on. By default, grid lines are named sequentially as A, B, C and so on, for the X direction, and as 1, 2, 3, etc., for the Y direction, but the grid line names are editable, and can thus be user-defined. This also applies to the general grids. Besides the Set Grid System Visibility command, you can also control grids visibility from within the grid data form, in a line-by-line fashion if necessary, by using the visible columns, on the definition of the grid lines, in X, Y, and general directions. Grid line names are displayed inside the bubbles. User can control if the bubble's location is at start, or end of grid lines, and size of the bubbles. Changing size of bubbles is reflected on Grid Sketch and will also be updated on the user interface, once form is accepted. Grid display colors can also be user-defined. By default, the grid lines are displayed in gray. When adding additional grid lines under X and Y directions, user can refer to Sort command, to reorder the grid lines by ascending order of their ordinates. The general grids offer the Sort by ID button, which tries to automatically reorder grid names alphabetically, or by ascending order of their numbers. A final note to say that ETABS also offers the possibility of importing the grid lines from a DXF file. Two options are offered here, one to add grid lines to the coordinate system currently highlighted on the list, and the other to create a completely new coordinate system, to which the imported grid lines will be added. In both cases, the new grid lines will be treated as general grids. Basically, ETABS imports the coordinates of both start and end joints of each line. When using each of the options, you're prompted with a form to select which AutoCAD layer contains the grid lines that you want to import, and in which units the file was prepared. Once this information is accepted, if you revisit the coordinate system to which the grid lines were added, you can confirm that the new grid lines have indeed been added as general grid lines. This concludes the revision of the Edit Stories and Grid Systems command. That being said, the next two commands under the Edit menu are still related with grids. Let's briefly discuss the features they offer. In many situations, you have objects on the model, with joints that don't necessarily lie over grid lines. This can happen, for instance, when you import geometry from other CAD platforms. If at some point, you'd like to access elevation views of the locations of these joints, you know that grid lines have to be added for that effect. Obviously, assuming you know the coordinates of the joints through which you want to pass grid lines, these can be added manually, inside the grid data form. Notwithstanding, ETABS offers a more expedited and automated way to accomplish this, with the Add Grid Lines at Selected Joints command. Now that you know that more than one coordinate system can be available on the model, it's easy to understand why the program requires user to specify to which coordinate system should the new grid lines be added. You can add grid lines parallel to X, in which case the software reads the ordinate of the selected joints, and adds corresponding grid lines under the Y grid data. You can confirm these were indeed added inside the grid data form, and that ETABS automatically sorted them by ascending order of their coordinates. In a similar fashion, grid lines can be added parallel to Y, in which case they'll be populated under the X grid lines, on the grid data form. The last option, offered by the Add Grid Lines at Selected Joints command, is to add the grid lines, specifying an angle measured with respect to the X global axis. In this case, the grid lines added will be included on the grid data form as general grids. Let's now imagine that you are well underway on modeling your structure, to the extent that you already defined your grid lines and added your geometry, and, being it because the project suddenly changed, or you accidentally used the wrong location for your grids, you find yourself in need to change the grid's location, and the structure geometry with it. Ideally, you wouldn't want to have to redo all the modeling. ETABS anticipates this need, with the command grid options, glue joints to grids. To illustrate this feature, let's focus on the template model we have on screen. As you can see, ETABS automatically populates dimension lines, based on spacing between grid lines available on the model. Similarly to grid lines, dimension lines do not affect model behavior, they are used to help on sizing the objects on the model. In this particular case, they show us that all bays are spaced at 8 meters. Anticipating that we will be moving the location of the grid lines, let's activate the command grid options, glue joints to grids. This command is a toggle. Please notice as the symbol becomes highlighted when the command is activated. You can then proceed to move the position of the grid lines on the grid data form. Let's for instance assume that the first X bay is 5 meters long, instead of the default 8. The grid diagram is immediately updated, showing the new location of grid line B. Once you accept the change on the grid data form, you can immediately see how ETABS updates the model in all working windows, reflecting the new position of the grid lines and structural objects. As a reminder, the glue joints to grids command is activated. This means that all joints move together with the grids. Moreover, frame and shell objects that are attached to the joint objects remain attached, thus moving or resizing as appropriate. There's a final grid command with which we want to make sure you're familiar with, and that one is the Edit, Grid Options, Lock on Screen Grid System Edit. Basically, this command allows you to reshape or delete any grids you may have added to your model, and though it's not explicitly mentioned, it also applies to any dimension lines you might have created. To help us better view the grids, let's momentarily hide all the structural objects on screen. The easiest option for that is right-clicking somewhere on the working window, outside the boundaries of the structure, and use Command Invert Visibility of Objects. Once we haven't previously selected any objects, ETABS interprets this as hiding all the objects in view, leaving just the grid lines visible. The Edit, Grid Options, Lock on Screen Grid System Edit command is a toggle, and is activated by default, as you can confirm when looking at the symbol, which appears highlighted with a blue square. If you think about it, it makes sense for it to be activated by default. Basically, the underlying idea is that on a regular basis, you wouldn't want to select or change your grid lines directly over the interface, so with this command activated, if you accidentally select a grid or a dimension line on screen, the grid doesn't get selected, and can't thus be inadvertently moved or changed. If you revisit the command, please notice as the symbol becomes grayed out, indicating that the command is now deactivated. With the command deactivated, user can proceed to select grids and dimension lines on screen, and edit or delete them as required. Grid selection works much in the same way as in AutoCAD, meaning, if you do a window selection from left to right, starting in an empty space located somewhere before the grids, only the grid lines that are fully enclosed on the selection window get selected. Grids that are selected are displayed with a dashed line. To deselect them, just hit the Escape key of your keyboard. Conversely, if you make a window selection starting from right to left, then all the grids that are included on the window selection, even if they are only partially enclosed, will get selected. Dimension lines, on the other hand, do not recognize window selection, that is, even if the dimension lines get fully enclosed on a window selection, they do not get selected. To select dimension lines, user needs to pick directly over them with the mouse. Selected dimension lines are displayed with a blue dashed line. When selected, user can delete them, either using the delete key of the keyboard, or referring to Command Edit Delete. This comes to show that when the Lock on Screen Grid System Edit command is deactivated, user is able to select and delete dimension lines, but that is as further as you can go with dimension lines. When the Lock on Screen Grid System Edit command is deactivated, grid lines can also be selected and deleted, but much more than that, user can actually tweak the grids on screen, using Command Reshape Object. After activating the command, user can pick a grid with the mouse, and its endpoints get highlighted, letting you know that the grid is selected. If you continue to click over the grid with the mouse, you can move it around, and drop it in a new location. Snapping to one of the grid points allows user to select the point. If user keeps holding down the mouse with the point selected, then he can drag the point to a new position. While you're dragging it, ETABS displays a dashed line, together with linear and angular dimensions, in an attempt to guide you to select the new location where to drop the point, all the while also allowing you to snap to grid points. If you reshape the grid line, such that it no longer follows in an X or Y direction, then the grid line is automatically converted into a general grid, defined by coordinates of its start and end points. Once any required changes to grid and dimension lines on screen are completed, user is advised to revert Command Edit, Edit Grid, Lock on Screen Grid System Edit, back to active, as to prevent user from accidentally making further changes. With this final command, we have now covered what we believe are the essential guidelines to work with stories and grid lines on ETABS. Thank you so much for watching. If you like this video, please don't forget to give us that thumbs up, so this video can spread to more people. If you want to check the next video on this series, you can visit it here. Check out our website, structuralacademy.com, for additional information on all the other courses we offer. And stay tuned on our channel for all our latest content.